Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. We are on chapter 11 and our topic for today is the functional group containing carbon, hydrogen and nitrogen. In our previous lecture, we discussed about some classes of compounds that were aldehydes, ketones, carboxylic acids and esters. So before moving towards our main topic, let's discuss some differences between aldehydes and ketones as well as the carboxylic acids and the esters. So first, moving towards the differences between aldehydes and ketone. These two classes of compounds are differentiated on the basis of the functional group. The general formula for aldehyde is RCHO. Here R may be hydrogen or an alkyl group. The general formula for ketone is RCOR. Now you may see here that in the aldehydes, this carbonyl group, that is C double bond O group, is attached to a hydrogen atom. However, in ketones, this carbonyl group is attached to alkyl groups on both sides. So whenever in a certain compound, if you see a carbonyl group attached to a hydrogen, you will quickly say that this class of this organic compound belongs to the aldehyde. However, if that carbonyl group is present between two alkyl groups, then you will quickly recognize that compound as the ketone. The functional group in aldehyde is CHO and the functional group in the ketones is C double bond O, carbonyl group. This is the general representation for aldehydes and this is the general representation for ketones. In the aldehydes, suffix al is used. In the ketones, suffix one is used. So if you're asked to differentiate between aldehydes and ketones, then you will write these points. And with these points, you may also draw the structure of some aldehydes or ketones as an example along with their names. So it would give a good impression to the examiner that you know well enough about the differences between the aldehydes and the ketones. Now let's discuss the differences between carboxylic acids and the esters. In the carboxylic acids, the general formula is RCOOH and the general formula in the ester is RCOOR. Now the difference in the general formula between these two classes of compounds is that here the carboxyl group, here the carbonyl carbon is attached to an oxygen atom and that oxygen atom is attached further to a hydrogen atom. However, in ester, the oxygen atom which is singly bonded to the carbonyl group is attached to an alkyl group on the other side. Functional group for carboxylic acid is COOH, also called as carboxyl group, and the functional group for ester is COOR. Carboxylic acids are generally represented like this and the esters are represented like this. For example, if this R is methyl, then the structure for this compound will be drawn like this. And similarly, for the esters, these two alkyl groups may be same or different. We have discussed about it in our previous lecture. So if they are same, then we have a structure like this. So this is an ester because here this oxygen atom is attached to an alkyl group. And in the carboxylic acid, this oxygen atom is attached to a hydrogen atom. For carboxylic acids, suffix OIC followed by the word acid is used. For the esters, suffix OATE is used. Now, you may also give examples and the name of those structures in order to differentiate between the carboxylic acids and the esters. So now let's move towards our main topic. The functional group that contains carbon, hydrogen and nitrogen belongs to the category or belongs to the class of compounds also called as amines or amines. These are the organic compounds which contain NH2, NHR or NR2 groups. These three groups are present in three different kinds of amines. However, your syllabus is limited to only one class of amine, that is the primary amines. But we will discuss all three types so that you may be able to differentiate organic compounds as amine wherever you see them or wherever you study these compounds. These amines are mainly recognized by the presence of C single bond N. Wherever you will see this bond, you will quickly recognize that compound as an amine. Examples for amine include methylamine, dimethylamine, trimethylamine. Now in all these compounds, you may see C-N bond, and because of this bond, these compounds are classified in the class of compound that is amines. So the functional groups in different kinds of amines are written as follow. In the primary amines, the functional group is NH2 and the general formula for primary amine is RNH2. In the secondary amine, the functional group is NHR and the general formula for the secondary amine is RNHR. Now here R is representing an alkyl group. In the tertiary amine, the functional group is NR2 and the general formula for the tertiary amine is RNR2. So let's discuss them one by one so that you can clearly recognize or understand these types of amines. So first one is the primary amine. This is the functional group in the primary amine and this is the general formula for the primary amine. These primary amines are mainly represented by the structure like this. Here you may see that nitrogen is having 3 bonds. You know that nitrogen needs 3 more electrons in order to complete its valence shell. So therefore it shares 3 electrons in its valence shell to form 3 more bonds. Nitrogen has a lone pair on it as well. Now in the primary amine, nitrogen atom is attached to only one alkyl group. The rest 2 bonds that nitrogen atom forms is with the hydrogen atoms. So you distinguish primary amine from the other amines through this basis that in primary amines, nitrogen atom is only attached to one alkyl group. Example for the primary amine is the methylamine. This is the structure for methylamine. Now in methylamine, you may see that only one carbon is directly attached to nitrogen. Therefore, it is considered as the primary amine. In this structure, this general formula is the condensed form of this structure and this NH2 is the functional group for the primary amines. Now moving towards the secondary amines, the functional group in the secondary amine is NHR and the general formula for the secondary amines is RNHR. The secondary amines are generally represented like this. Here you may see that nitrogen atom is attached with 2 alkyl groups and 1 hydrogen atom. In the primary amines, we saw that nitrogen atom is attached to only one alkyl group and two hydrogen atoms. Whereas in the secondary amine, nitrogen atom is attached to two alkyl group and only one hydrogen atom. Example for secondary amines include dimethylamine. Now, since this nitrogen atom is attached to two carbons, so therefore this amine is considered as the secondary amines. This general formula is the condensed structure formula for this representation, and this NHR is the functional group for the secondary amines. Now moving towards the tertiary amines, the functional group for tertiary amines is NR2, and the general formula for tertiary amines is RNR2. Tertiary amines are generally represented like this. Here you may see that nitrogen atom is directly attached to three alkyl groups and no any other hydrogen atom is attached to the nitrogen atom. So this is how you differentiate tertiary amines from primary and the secondary amines. Example for the tertiary amines includes trimethylamine. Now since this nitrogen atom is connected to three carbon atoms, therefore it is considered as the tertiary amines. So let's do an example. We have to classify the following organic compounds on the basis of functional group. First one is a common solvent for organic materials such as fats, rubbers, plastics and varnishes. And second one has a foul or irritating odor. Third one is present in the vinegar and is used to flavor foods and making a polymer called as polyvinyl acetate. Now you have just to identify them. In order to identify them, first always write the general representation, that is the condensed structural formula for these compounds. Condensed structural formula that is used generally for each class of compound, you will write that formula, and after writing that formula you will distinguish these classes of compounds in different classes. For example, this one CH3C double bond OCH3 is a ketone. This compound CH3CH2CHO, this one is an aldehyde. And this CH3COOH is a carboxylic acid. So whenever you write a general formula for these classes of compounds, you can quickly recognize the given substance as aldehyde, ketone, carboxylic acid or any other class of compound. Next, we have to identify the following compounds as an aldehyde or a ketone or a carboxylic acid. We have done this self-assessment exercise in our previous lecture as well. Let's quickly revise that. We have three classes of compounds: aldehydes, ketones, carboxylic acids. Generally, they are represented like this. So, this one, if you look at this one, then you may see here that this structure may be simplified as this. CH3 is an R group, CH2, CH3 is also an R group. So, this means that carbonyl carbon is present between two alkyl groups, so it is a ketone. Now, if you look at this structure, you may quickly recognize or generalize it like this. Now this hydrogen atom is attached to a carbonyl group. Whenever hydrogen atom is attached to a carbonyl group, it is referred to as an aldehyde. Here you may see OH is attached to a carbonyl group, so this means that this is a perfect example for the carboxylic acids. Identify the types of following compound as an alcohol, aldehydes or ketone. First one has the structure like this. Now you may see here a hydrogen atom is attached to a carbonyl carbon, therefore it is an aldehyde. Second one has the structure like this. Now since this carbonyl carbon is present between two alkyl group, therefore it is a ketone. In the third one, you may see here that this OH group is attached with an alkyl group, therefore it is an alcohol, because in alcohols the functional group is OH. Identify the following compounds on the basis of functional group they contain and encircle the functional group. Now, taking this compound, you may see here the presence of C double bond C. Any compound which contains C double bond C is classified as alkene. So this C double bond C is the functional group here. In the second category, this COOH is the functional group here, and because of the presence of this functional group, it is classified as carboxylic acids. Same is the case for the third category. This COOH is the functional group and it is also a carboxylic acid. Now if you look at this compound, you will see that a carbonyl carbon is present between two alkyl groups. So this carbonyl group is a functional group here and it is a ketone. Taking this organic compound, you may see that this is the functional group for this compound, C double bond OO, and R group is attached on both sides. So this is the functional group, and this functional group is present in esters. So this compound is an ester. In the last one, this C double bond OH is the functional group, and if a hydrogen atom is attached to a carbonyl carbon, then it is classified as aldehydes. So let's do some MCQs from your review exercise. The functional group C double bond O is found in, out of these options, ketones is the correct option, because in ketones this carbonyl group is present between two alkyl groups. In alcohols OH group is present. In carboxylic acid, C double bond O along with OH is present, and in the ester, C double bond O along with OR is present. So the correct option for this MCQ is ketone. Second one is, in which of the following compounds oxygen is attached to two alkyl carbon atoms? Now if you write the general representation for alcohol, it is ROH. For phenol, it is OH. For ethers, general representation is ROR. And for esters, the general representation is RC double bond OOR. Now if you look at the general representations for all these classes, you will quickly recognize that it is the ether in which the oxygen atom is attached to the two alkyl carbon atoms. Now in the carboxylic esters, in the esters, this oxygen atom is attached to two carbon atoms, but this carbon atom is not considered as an alkyl carbon, because the alkyl carbons do not form a double or triple bond with any other atom. These alkyl carbons are always single bonded. So this carbon of carbonyl group cannot be considered as an alkyl carbon. Which of the following is an alcohol? Now for alcohols, you have general formula ROH. Now out of all these options, this option is the correct option, because here this R group is the ethyl. You cannot consider this as an alcohol. It is a phenol, because here OH group is attached to a benzene ring. The functional group of amines is, we just read it today. Since in your syllabus book only the primary amines are discussed, so we will look for the functional group of the primary amines, and the functional group for the primary amines is NH2. Formic acids contain a functional group. The word acid means here that this compound is a carboxylic acid. So in the carboxylic acid, this carboxyl group is present. So formic acid contains this group. So this was all for today. Here is a question related to the topic of functional groups. You have to answer it in the comment section. Name the functional groups containing C double bond O group. You have to name all those classes of compounds which contain C double bond O group in it. Please write the name for those classes of compounds in the comment section below. This was all for today. We just completed our topic for functional groups. Thank you for being with me.